Today's topic is quadratic equations in Vertex form, and today is May 6th. Our note packet has 4 pages. This entire unit has been focused on quadratic equations. In the last 2 lessons, we have been learning to graph quadratic equations, and we've also learned that the vertex is an important part of the graph. The vertex is where the graph will stop and change direction. And we also know that the axis of symmetry will pass right through the vertex. We typically like to have our quadratic equations written in standard form so that we can identify the values of a, b, and c. But if we manipulate the function, we can actually reveal the location of the vertex. If your quadratic equation is in vertex form, it will look like this generic model, and we typically see some kind of binomial raised to a second power. The value of h and k in the function serve as the vertex of our parabola. You'll notice in the red function it's negative, but when we actually state the vertex, the value of h is positive. So that is one thing that we'll have to remember. The x value lies to you, and the y value tells the truth. For this first example, we're looking for the location of the vertex. So, using the vertex form, we're simply going to extract the information, and my vertex is located at +1, +5. In example 2, again, we're already in vertex form. So the vertex is located at -4, -6. If the quadratic equation is in standard form, we can change it into vertex form by using the completing the square method. We're going to try that now with example 3. When we complete the square, we like to keep the quadratic term and the linear term on the same side, and we like to move the constant to its own separate side. Normally, we would see 0. We do not want to change this to a 0. We want to leave it as a y, so that when we're done, we'll still have a function that says y equals. So we're going to start by subtracting 71 from both sides to move that constant over. And the procedure for completing the square says I'm going to take 16, divide it in half, and then square it. So half of 16 is 8, and 8 squared is 64. We will place that value on both sides to balance our equation. On the left, I'm going to combine my like terms, and on the right, I'm going to write this as a product of 2 identical factors. The last step is to add 7 to both sides so that y is all alone. And now our equation is in vertex form. We can now extract the vertex from it, and the vertex is located at -8, +7. In example number 4, we're going to start the same way. We're going to add 59 to both sides so that the quadratic and the linear term are by themselves. You'll also notice that the value of x squared, the coefficient is -1. We really want this to be +1, so I'm going to remove a GCF of -1 from both the quadratic and linear terms. Now I'm going to move forward with the completing the square process. On the right-hand side, we're going to divide 14 by 2, which is 7, and 7 squared is 49. But when you fill in the left side to balance the equation, remember we have to multiply 49 times the -1, which is our GCF, so that we fill it in appropriately. So on the left-hand side, it's -49. We're going to simplify our constants to +10. And we're going to leave the -1 outside and write our 2 identical factors. The last step is to subtract 10, and now we're able to extract our vertex from the function, and it's located at -7, -10. In number 5, we see an incomplete quadratic. There's no constant. So we can go right to the completing the square process. So on the right-hand side, half of 4 is 2, and 2 squared is 4. So we're going to add 4 to both sides. On the right-hand side, we're going to write this as a product of two identical factors. They're both x plus 2. And in the final step, we're going to subtract 4. So now we've accomplished our vertex form, and the location of our vertex is at -2, -4. In number 6, we're going to start by subtracting 5 from both sides. You'll notice on the right-hand side that both the quadratic and the linear term do have a greatest common factor that should be removed. So I'm going to go ahead and remove the 2. And now that the quadratic term has a coefficient of 1, I can start to complete the square. So half of -2 is -1, and -1 squared is +1. So on the right, we're using +1, but remember 1 times the GCF of 2, I need to fill in with 2 on the left-hand side. We're going to go ahead and add -5 and 2 on the left. And we're going to write our perfect square trinomial as two identical factors. And then I'm going to add 3 to both sides. So my vertex is located at 1, 3. With example number 7, all the terms are mixed up. So I'm going to move y to the left and the linear term and the constant to the right. So now we do have standard form. So we're going to move the constant back over. So we're going to add 731. And at the same time, I'm removing the greatest common factor from the quadratic and the linear term. Now we're going to force a perfect square trinomial. Half of -18 is -9, and -9 squared is 81. So that's the value I've placed on the right. When I place the value on the left, it's 81 times -9, which is -729 to keep the balance. We're going to combine our like terms and write our factors. And we're going to subtract 2. So now our vertex is located at +9, -2. Hopefully you're getting the hang of this. This example is very tricky. We're not going to see a lot of these, but as you move on to Algebra 2 in the future, this is the type of factoring that you're going to work with. So I'm going to start by adding 1 to both sides. The quadratic and the linear term do not have a greatest common factor, but I need the quadratic term to be 1x squared. So I am removing 3, but I'm also dividing 2 by 3. So this is going to leave 2/3 as a coefficient. I did this on my iPad, but 2/3 divided by 2 will give me 1/3, and 1/3 squared is 1/9. So on the right, I'm using 1/9 to complete my square, but I need to multiply 1/9 times 3 to complete the square on the left. So I'm actually only adding 1/3. Now, when I combine my constants, I'm going to make this whole number 1 3/3, so that I'll get 4/3. And then I'm going to write my perfect square trinomial as a product of two factors. So this is x plus 1/3, and then x plus 1/3. We're going to simply subtract 4/3. And even though they're fractional, the vertex is located at -1/3 and -4/3. This is one that on the iPad, you would not be able to locate it well. These would show up as decimals, and the iPad table never display the decimal values. In fact, you would not even see the repeating pattern on this table. Our last type of examples, if you're provided a quadratic equation in vertex form, sometimes they ask you to put it back into standard form. So in example number 9, that's exactly what we're going to do. Because x minus 1 has two identical factors, I'm going to ask you to expand that and write it twice. I'm going to simply focus on these two binomials and distribute. The 2 as the GCF is going to hang around, but I'm going to have x squared minus 1x to give me negative 2x, and then plus 1. Now I'm going to distribute my 2. And then ultimately, I'm going to add the 2 and the 5 together. And now I have a quadratic equation in standard form. Let's do one more in example 10. We're going to start by writing x plus 4 twice so that we don't lose any terms. And then I'm going to focus on distributing the x plus 4s. So when I do that, I should have 3 on the outside and then 4 resulting terms. Because I'm going to have 4x plus 4x, I've combined them already to 8x. I'm going to distribute my 3 and then subtract 6. And there's my quadratic equation in standard form. Your homework tonight is number 111. You'll see it's a one-sided paper and it'll say converting quadratics to vertex form. If you have any questions, please feel free to email me at any time. I'm always checking my email, and have a great day.